Alright, so today we're going to have a video about estimating, accuracy, and precision. So of those, the first one that we're going to start talking about is estimating. So how we do it and really what it is. So estimating, an estimate is an approximation of a number based on reasonable assumptions. Kind of a real important thing, it's not a guess. We're not just blindly guessing. It's an approximation, meaning on average or about, it'll be this number of things or about this far of a distance or this length. And we make some assumptions while we're doing this, some reasonable assumptions. Which will show an example of that in just a second. So if we do that, let's estimate on the left how many dots are in the red box. So if we can count, okay, 1, 2, 3, 4, 5. Okay, that was easy. How will we estimate the number of dots without counting them all? So when we're talking the number of dots in this whole thing, this whole grid, how are we going to figure out the number of dots? Well, we can just say, well, I know there's 9 boxes because 3 by 3, and so I can do 9 times 5 because there's those 5 dots, making the assumption that all the boxes have about 5 in them. And by doing so, that'll give me an approximation, which is my estimate. So I take 9 times 5, and I'm going to get 45 total dots, right? So I do 9 times 5, so about 45 dots. Now, well, I said we made that assumption that all these boxes have 5, and now you may already be thinking, well, I'm looking, and okay, this one has 5, that only has 4, this only has 3, this only has 2. Yeah, but these also have 6, and so really on average. Now, it won't be exact, you can go through and count all of them to find the exact answer, but that takes more time. We talked about in class how a example of this is if we're trying to figure out the population of, say, oak trees in a forest. Well, some forests are really big, and it's really hard to go around and actually counting them. So we'll make the assumption that there's roughly the same amount of oak trees in a given spot as there are in the rest of the forest. So we make a plot not unlike here on our screen, except in this case now those dots would represent maybe the number of oak trees. So we count them up and then we approximate that, okay, in this box, or we approximate our answer based off the assumption that there's some 5 oak trees here, so on average in the plot that we have there'll be another 5, and so we can then figure out really entire forest, which can save us a lot of time instead of having to walk through this forest counting all the oak trees, which would be very time consuming and you could miscount just as easily. So this will get us really close to the exact answer. So the next one I'm going to talk about is accuracy and precision. Now we can use these words to describe our data or even our estimates that we just talked about to see how accurate and precise they are. So let's talk about what those two things are. So the first one is going to be accuracy. So accuracy refers to the closeness of a measured value to a standard or known value. Really what this is saying is how close are we to the correct answer. Accuracy is all about being correct. In this case, on this image here, right, we want the bullseye when we're shooting arrows, and so the perfect would be right here in the middle, and so accuracy is how close we are to that point. The image on the left shows great accuracy as all shots hit the bullseye. Right, so we're very accurate, and we'll talk about how precise we are, because those are separate things in just a moment. Precision is all about the closeness of 2 or more measurements to each other. So really, this image shows precision, but poor accuracy. So we just mentioned that our accuracy, we want our accuracy to be right here, kind of in the middle, and you can't see my dot pointing, but it should be right in this big center point right here. And here's where our targets hit, or our arrows hit the target. They're pretty well close together. You can tell it's precise in a way, because if I were to ask you the question, where do you think the next dot is going to appear, you're going to say maybe right around here. It makes sense. All the other ones are in this spot. However, we're not really at the target where we want to be. So in this case, all the arrows are tightly clustered, but not in the desired location. They could be, but they don't have to be in order to be considered precise. Precise is about how close all of our measurements are to each other. Now, here is an example of no accuracy and no precision. So our image on the left shows no accuracy and, well, no precision. All of our arrows missed our target pretty horribly, and that's why it's showing that. And if I were to ask you, well, where do you think the next arrow is going to go? About as much as you could tell me is probably not the target, but it could be a huge amount of area where it could go. So that's why I also know it's not very precise. Our arrows are all over the place, and it's not very accurate because they're not hitting our desired target. Now, in contrast to the one we just looked at, this is an example of one with accuracy and with precision. So this image shows both accuracy and precision. All arrows hit the target and they're very close to each other. So in this case, all of our arrows are right here in the middle, dead center, about as close as they could really get, which makes them very precise, and it's very accurate because this is exactly where we want them in this scenario. So it's very accurate and it's very precise. This is the ideal situation. This is what you want, well, both when you're shooting arrows and when you're conducting experiments. You want your numbers or data to be accurate and very precise. All right, so now let's answer the following questions to see how well we're understanding this. So we have 4 targets, A, B, C, and D, and we got to answer a couple of questions about them. Question number 1, which has good accuracy but low precision? Okay, take a second to pick which one you think that is. All right, so which one has good accuracy but low precision? The best answer, letter C. Now, if we look at letter C, you can tell that all those darts they hit the target, they're pretty close to the middle, but they're not really close to each other. They're kind of spread out. So it's going to have pretty good accuracy, but ultimately pretty low precision. And honestly, the accuracy isn't that great either, but given our options, that's the best choice. All right, moving on to number 2, which has good precision but low accuracy. So again, take a second, pick your choice. All right, so good precision but low accuracy. It's going to be letter B. So now looking at letter B, you can see that our darts are pretty close to each other. They're all within the same spot, but they're not really near our target. So we were consistent in the fact that all of our darts are in the same spot, but they just weren't where we wanted them to be. All right, question number 3, which has good accuracy and precision? So looking, you're looking between now options A and D, and well, you can tell that, well, D is going to be both accurate and precise. All of our darts are right there in the middle, and they're pretty well close to each other. If I say, all right, well, if I'm throwing a 5th dart, where is it going to go? You're going to say, well, bullseye, because that's where all the other ones went. Which is low accuracy and precision? Well, that's the only one that we have left, and that's going to be letter A. And looking at it, you can tell, right? I mean, all of our darts aren't really near our target. There's maybe one that's sort of near, but the rest of them aren't, and they're not really close to each other either. So we don't really have good accuracy or precision. And that just about wraps up this video on estimating accuracy and precision. If you have any questions on either of these concepts, please talk to me in class.